Okay guys, so today we're going to talk about quotient rule, and basically in this video I'm going to teach you about quotient rule, then ironically I'm going to tell you why you'll never need quotient rule and why you only have to remember product rule. Okay, so let's get started with how I usually do this by just taking a derivative of a quotient. This is what quotient rule is for, finding the derivative of a function where a function is divided by another function. And basically what I'm going to do is I'm going to take a simple derivative and then I'm going to write it out symbolically, and then I'm going to teach you how you can get the same derivative with product rule, but you'll basically have to remember a lot less. So okay, so let's say I have f of x, and I say that this is equal to 5 over, let's say, 23x. Okay, I don't know. That seems good enough for me. So yeah, so let's have some symbolism here. So let's say that our g of x, our first function, will be equal to 5, and our h of x will be equal to 23x. Okay, so basically if you were like to substitute in these values right here into here, basically you're saying that f of x is equal to g of x over h of x. I hope you can see that. So basically when you want to take the derivative, and I'll just write the derivative out right now. I'll just do it quickly for you, and then we'll go backwards. Yeah, so dx of f of x is equal to basically 0, because basically what you do is first you take the derivative of your g of x, which in this case it's 5, and the derivative of a constant is 0, and then you multiply it by the second one. I mean, it won't be a really big deal because this will obviously cancel out, but for now we'll just write it so that you see it. So you take the derivative of g of x, and then you multiply it by h of x, and then you subtract. So this is very similar. This is basically exactly similar to the product rule pretty much up to this point, except it will be a subtraction sign. So now you take, you write g of x, and then you take the derivative of h of x. Okay? So basically here you took the derivative of g of x and left h of x alone, and here you left g of x alone and you took the derivative of h of x. Now this looks very similar to the product rule. It's just this negative sign. Now what you do is you divide this all over by hx squared. So you just do 23x and you square it. Okay? So after we simplify this, what will we get? We'll basically get that this is equal to, and I'll write over here, that this is equal to negative 115 all over 23x squared. Okay? So okay. So basically, now let me show you how you can get the same answer with the product rule. Okay? So, and this is why product rule is more efficient. Well, first off, let me just write the symbolic representation of this, okay? Of our quotient rule, because it's very important. I don't use quotient rule personally. I only use product rule because it's a lot easier for me, but perhaps quotient rule will actually be easier for you, so I think that will be important to write this. So dx of f of x will be equal to, so you basically take the derivative of g of x and multiply it by h of x, and you subtract that from h prime of x, and you multiply that by g of x, and you put this all over h of x, not h prime of x, hx squared. Yeah, so basically this is the symbolic representation where, you know, g of x is basically your function in the numerator and h of x is your function in the denominator. And this would be the symbolic representation of it. So, yeah, let me show you the way of doing this with product rule now. So we have our f of x, right? And we've said that it's 5 over 23x. 5 divided by 23x. So is there a way that we can rewrite this? I mean, if obviously I want to do product rule, I have to make this a product of two functions, right? So how would I rewrite this as a product of two functions? Well, it has to do with this being in the denominator. What do we know about things that are in the denominator? Well, they can be rewritten with an exponent of -1. So this right here, this guy right here, 5 over 23x, is equivalent to 5 times 23x to the -1 power. These are equivalent statements, okay? So, and to do this, technically you need both product rule and chain rule to do this, but yeah, you should be able to do this. So, what did we say it was? Well, you know, let's find the derivative of this, and then I'll banter my shenanigans. So d of dx of f of x is equal to. So now we have a product here. What did we say? How did we do product rule? So we'll write the first one, which is 5. So we just wrote 5. Now we'll take the derivative of the second one. But what is this? What we'll have to do chain rule here, right? Because, right, we'll have to bring this through and blah blah blah, and we'll just do this, right? So this will be -23. Well, it will be negative actually 23x to the -2nd. Okay? And do you see how I did that? And then we have to we have to write that to the -2nd power, because, right, we brought down this negative sign. We basically did our chain rule idea, and now we have to subtract 1. So -1 minus 1 is -2. So, but we're not done yet. We still have to take the derivative of what's in here, right? Because we're not done yet. We just did the first part. So the derivative of this is 23. So now we add, and now we're on the second part. So we write the second one, which is 23x. Oh my God, math is going to come together here. It's so beautiful. So the -1, and now we take the derivative of 5, which is 0. So this cancels out, right? Okay. So what will we get here when we clean this all up? And it's going to be a very great thing, because as I knew, mathematics was going to work out, as it always does. And yeah, so what did we get there? We basically got -5 times 23 times 23x to the -2. Well, that surely looks different than -115 over 23x squared. Well, I'm sorry, adventurous pupil, but that is actually, if you rewrote this, right, because of this exponent, this means that this is in the denominator to the second power. So what is this equal to? What is this equal to? This is equal to negative 115, because negative 5 times 23 is negative 115. And then this is over 23x squared. Look at that. We got the same exact derivative using product rule as we did quotient rule. So they are in theory the same thing. I typically like to use product rule more because especially if you get to more complex derivatives, it's just easier to use product rule than quotient rule. But some people really like quotient rule. Like, I know a lot of people that love this thing and they think I'm crazy for using product rule, but nonetheless, it's just another option. Basically, you know, if you have the quotient rule, you basically, like I said, you just do your quotient rule derivative. But if you want to do the product rule, all you have to do is you just have to write it as a product of your, you know, your numerator times your denominator represented with its negative exponent requirement, i.e. if it's like to the first power, it will be -1. If it's to the second power, it will be -2, so on. And then you just take your derivative like it was a product, but you'll need chain rule for that as well. So it does come with its positives and negatives. But yeah, this is quotient rule. So this will be the end of the video, and yeah, I'll catch you guys later.